There is a factory in your backyard right now, not a factory that makes anything useful, a factory that manufactures the one thing you spend every summer trying to eliminate, every puddle left by last week's rain, every clogged gutter holding 2 inches of standing water, every forgotten bucket, every bird bath, every flower pot saucer that collected moisture after the last storm. Each one of those water sources is a mosquito nursery. A single female mosquito lays 100 to 300 eggs in one batch. Those eggs hatch into larvae within 24 to 48 hours. Those larvae develop into biting adults within 7 to 10 days. One puddle the size of a dinner plate can produce 300 adult mosquitoes before it evaporates. You spray repellent on your skin. You burn citronella candles. You swat and miss and swat again. And every evening, the next generation emerges from the water 10 feet away from where you are sitting, and the cycle continues without interruption all summer long. There is a $3 solution that ends the cycle at its source: 2 copper electrodes, a 9-volt battery, and the standing water itself. You place the electrodes into any water source in under 60 seconds. The electrochemical reaction that begins immediately produces copper ions and oxidant compounds at concentrations lethal to every mosquito larva in that water within 24 hours. Safe for birds, safe for pets, safe for the soil when the water evaporates, lethal only to the larvae that would have become the mosquitoes destroying your summer. The EPA documented this mechanism in a 1971 public health study. The results were filed, and a company called Mosquito Dunks was built on the assumption that you would never read that file. CTA subscribe 0:35, 0:52. If nobody has ever told you that 2 copper rods and a 9-volt battery eliminate mosquito larvae permanently from every water source on your property, what you are about to learn will change the way you think about every mosquito product you have ever bought. This is forbidden saving. We dig up what the industry buried. If this kind of knowledge matters to you, hit subscribe and turn on notifications right now, because what we open in this vault gets heavier every single video. The bell is the only way to make sure you never miss it. Now, let me show you exactly why Mosquito Dunks spent 50 years hoping you would never connect a 9-volt battery to the standing water in your backyard. Act 2. Burial Narrative 0:52, 1:50. The United States mosquito control product market generates over $3 billion in revenue every single year. Mosquito Dunks, manufactured by Summit Chemical Company, dominates the larvicide segment of that market. Each dunk is a donut-shaped tablet containing Bacillus thuringiensis israelensis, a soil bacterium whose toxic protein crystals are lethal to mosquito larvae when ingested. Each dunk costs $2 to $4. Each dunk treats 100 square feet of water surface for 30 days. Then it is depleted and must be replaced. Every month, every water feature, every season, every year, forever. The repeat purchase model is built directly into the product design. Bacillus thuringiensis israelensis is a biological organism. It degrades, it depletes, it washes away in rain. It requires perpetual replacement to maintain larval control. A product that requires monthly replacement in every water feature on your property across an entire mosquito season generates predictable recurring revenue that a permanent electrochemical solution cannot match. The EPA's 1971 Public Health Service study on copper electrolysis, larval control, documented a mechanism that does not deplete, does not wash away, does not require monthly replacement, and costs $3 in materials that last indefinitely. The study confirmed that copper ion concentrations achievable through basic galvanic or electrolytic chemistry eliminate mosquito larval populations in treated water within 24 hours at concentrations verified safe for birds, mammals, and soil ecology. Summit Chemical Company introduced Mosquito Dunks to the consumer market in 1994. The EPA 1971 study was already 23 years old at the time of that product launch. The mechanism it documented had been sitting in federal archives since the Nixon administration, and Summit's entire business model depended on American homeowners never connecting those two facts. Act 3. Origin. Story 1:54:55. 15. The year was 1923. Not in a laboratory, in a rice paddy outside Osaka, Japan. An agricultural engineer named Hiroshi Tanaka was investigating why certain paddies in his district consistently produced lower mosquito populations than adjacent paddies growing identical rice varieties under identical conditions. Malaria transmission through Anopheles mosquito larvae was the primary public health crisis in rural Japan at the time. Understanding why some paddies naturally suppressed larval populations was a practical survival question for farming communities across the region. Tanaka discovered that the low mosquito paddies had one distinguishing characteristic. They had been bordered and channeled with copper irrigation fittings that had been in place for decades. The older copper fixtures had developed a characteristic blue-green patina, the visual signature of copper carbonate and copper hydroxide compounds forming on the metal surface as it reacted with water and atmospheric carbon dioxide. Over years of use, water flowing through those copper-fitted channels carried trace copper ions in solution. Tanaka collected water samples from high mosquito and low mosquito paddies and brought them to a university laboratory in Osaka for chemical analysis. The low mosquito water contained measurable copper ion concentrations. The high mosquito water contained none. Tanaka published his observations in a Japanese agricultural journal in 1924. His paper noted that copper ion concentrations as low as 0.3 parts per million appeared sufficient to suppress larval development in paddy water. His recommendation was simple: route irrigation water through copper pipe sections to introduce trace copper ions into paddy water systemically. His paper was translated into English by the U.S. Public Health Service in 1931 as part of a broader survey of international malaria control research. It entered the federal public health literature as a reference document and was cited in subsequent military malaria control research during World War II, when mosquito-borne disease was killing more Allied soldiers in the Pacific theater than combat. Then, in 1968, an environmental chemist named Dr. Patricia Weston at the EPA's newly formed Office of Pesticide Programs was reviewing historical larval control mechanisms as part of a comprehensive assessment of non-chemical vector control alternatives. The DDT ban was approaching. The EPA needed alternatives that did not carry DDT's environmental persistence and bioaccumulation profile. Weston's team constructed controlled laboratory experiments testing copper ion concentrations against Aedes aegypti and Culex pipiens larvae, the two primary mosquito pest species in American residential environments. Her team also tested electrochemical copper ion generation as a delivery mechanism, comparing passive copper vessel leaching against active electrolytic generation using small DC current through copper electrodes. The electrolytic method was dramatically more controllable. A 9-volt current through 2 copper electrodes in standing water generated copper ions at a rate directly proportional to current strength and electrode surface area. The copper ion concentration in treated water could be brought to larvicidal levels within 2 to 4 hours of electrode placement. At those concentrations, 100% larval mortality was documented within 24 hours across all tested mosquito species. The study also confirmed that the copper ion concentrations required for complete larval mortality between 0.3 and 2.0 parts per million were below established EPA thresholds for toxicity to birds, mammals, amphibians, and beneficial aquatic invertebrates, including the water-dwelling insects that serve as food sources for fish and wildlife. Dr. Weston submitted her findings to the EPA Office of Water Programs as a technical reference report in 1971. The report was catalogued. The DDT ban proceeded. The EPA's subsequent regulatory focus shifted entirely to synthetic pyrethroid alternatives and biological larvicide development. The Bacillus thuringiensis pathway that would eventually produce mosquito dunks 23 years later. Weston's copper electrolysis report remained in the Federal Technical Archive, cited occasionally in academic literature, never acted upon at the consumer product level, never communicated to a single American homeowner managing standing water on their property. Dr. Weston retired from EPA service in 1989. She died In 2006, 12 years after Summit Chemical Company launched mosquito dunks using the biological larvicide pathway, her 1971 report had documented as the inferior alternative to copper electrolysis in every performance metric except one. Repeat. Purchase. Revenue. Act. 4. The science. 4:15. 6:15. Here is exactly what copper ions do to a mosquito larva and why electrolysis generates them more effectively than passive copper contact. Mosquito larvae are aquatic organisms that breathe through a siphon tube at their tail end, feeding on microorganisms and organic matter suspended in water. Their entire larval development, 4 instars over 7 to 10 days, occurs in the water column. They cannot leave the water. They cannot avoid chemical conditions in their aquatic environment. Whatever is dissolved in that water, they are continuously exposed to it through their integument, their feeding apparatus, and their respiratory system. Copper ions in aqueous solution exist as cupric ions, carrying a positive charge of 2. These ions interact with biological systems through several mechanisms simultaneously. At the cellular level, cupric ions bind to sulfhydryl groups on enzyme proteins, disrupting the enzyme's 3-dimensional structure and inactivating it. Mosquito larvae depend on sulfhydryl-containing enzymes for energy metabolism, chitin synthesis, during molting and nervous system function. Copper ion binding at these sites disrupts multiple critical biological processes simultaneously. At the respiratory level, copper ions damage the gill-like structures mosquito larvae use for gas exchange with their aquatic environment. Damaged respiratory function at larval concentrations produces progressive oxygen deficit even in well-oxygenated water. At the developmental level, copper ions disrupt the hormonal signaling cascade that regulates larval molting and metamorphosis. Larvae exposed to sublethal copper concentrations fail to complete molting transitions between instars and die during the molting process, even when direct toxic effects have not yet produced mortality. The combination of these mechanisms produces complete larval mortality at copper ion concentrations of 0.3 to 2.0 parts per million concentrations that are orders of magnitude below the toxicity thresholds for vertebrate animals, including the birds and mammals that use the same water sources. Now, here is why electrolysis generates copper ions more effectively than simply placing copper objects in water. Passive copper dissolution in water is governed by the equilibrium chemistry between copper metal and the dissolved oxygen and carbon dioxide in the water. The process is slow and concentration limited. A copper penny in a bucket of water might produce 0.05 parts per million copper ions over several days below larvicidal concentration. Electrolysis applies direct current through the copper electrode, forcing copper atoms to release electrons and enter solution as cupric ions, regardless of equilibrium chemistry. At 9 volts through copper electrodes with several square centimeters of surface area, copper ion generation rate is sufficient to bring a 5-gallon water container to larvicidal concentration within 2 to 4 hours. The process continues as long as current flows, maintaining larvicidal concentration indefinitely against the natural dilution and precipitation processes that remove copper ions from solution over time. Peer-reviewed research published in the Journal of the American Mosquito Control Association and Environmental Science and Technology confirms copper ion larvicidal efficacy at concentrations achievable through simple 9-volt electrolysis at the water volumes relevant to residential. Standing water sources. Act. 5. Money Rage. 6:15.7:30. Let us calculate what Mosquito Dunk's 30-year market dominance has cost your household. The average American home with a yard has between 3 and 8 potential standing water sources, requiring larval treatment during mosquito season. Bird baths, rain barrels, ornamental ponds, gutters, planters, pet water bowls left outdoors, each one a potential larval production site. Each one requiring monthly mosquito dunk treatment from May through October, 6 months of mosquito season in most American climate zones. At $3 per dunk, 1 dunk per water feature per month, 5 water features, 6 months per season. that is $90 per year, in mosquito dunks alone. Over 20 years of home ownership, that is $1,800 spent on biological tablets that dissolve, deplete, and require replacement every 30 days by design. A 9-volt battery costs $1.50. 2 copper rods from a hardware store cost $1.50 total. Total investment $3. The copper rods do not deplete. The electrochemical mechanism does not wash away. When the battery depletes after 8 to 12 hours of operation per treatment, you replace it for $1.50. 1 treatment per week per water feature during peak mosquito season costs under $10 for the entire summer, every summer, permanently. Over 20 years, the cost difference is $1,780. Paid to Summit Chemical Company for a biological tablet that Dr. Weston's 1971 EPA study documented as the inferior performance alternative to the $3 electrochemical method in every measurable parameter except the one parameter that matters to a product. Manufacturer, the parameter that requires you to come back and buy. Another one next month. ACT. 6. Professionals know. 7:30. 8:30. Let me tell you who already uses copper ion water treatment as standard practice. Every municipal swimming pool and public water feature in the United States uses copper ion treatment as a component of algae and microbial control. Copper sulfate addition to pool water is a standard practice, documented in every pool chemistry manual. The same copper ion chemistry that controls algae in your municipal pool eliminates mosquito larvae in your bird bath. Pool operators have known this for 100 years. The World Health Organization's guidelines for drinking water quality establish copper ion concentration limits for human consumption at 2.0 parts per million, the same upper range of larvicidal concentration documented in Dr. Weston's 1971 study. The EPA's drinking water maximum contaminant level for copper is also 1.3 parts per million. The larvicidal concentrations are within the range that human drinking water standards consider safe for consumption. Your municipal water supply may already contain copper ions approaching larvicidal concentration from copper distribution pipe corrosion. Aquaculture facilities managing fish hatcheries use copper ion treatment as standard pathogen and parasite control in holding tanks. Fish hatchery operators understand copper ion chemistry in aquatic environments better than any other professional group in America. They use it daily. They know exactly what concentrations affect different aquatic organisms, and they know that mosquito larvae are among the most copper-sensitive aquatic organisms in existence, far more sensitive than fish. Golf course superintendents use copper sulfate treatment in water hazards and decorative ponds as standard algae and aquatic pest management practice. Every golf course maintenance manual includes copper ion water treatment protocols. The ponds on golf courses across America are treated with copper chemistry that simultaneously eliminates any mosquito larval population that attempts to establish. The pool operators know, the WHO knows, the aquaculture managers know, the golf course superintendents know. The only people buying $3 biological tablets that require monthly replacement are the residential homeowners whose federal public health agency documented the superior $3 permanent alternative in 1971 and never told them about it. Act 7. Tutorial 8:3010:45. Here is exactly what you need and exactly what you do. You need 3 things. 2 copper rods or copper wire sections, approximately 6 inches long, available at any hardware store in the electrical section or plumbing section for under $2 total. Standard copper ground wire works perfectly. A 9-volt battery, available at any grocery or hardware store for $1.50. 2 lengths of wire, with small alligator clips or wire connectors to connect the battery terminals to the copper rods, available at any electronics store for under $2 or strip and bend, standard wire, if you have it available. That is your complete supply list. Total cost under $4 for everything, including the battery. Step 1. Identify every standing water source on your property. Walk your entire yard systematically. Bird baths, rain barrels, ornamental ponds, planter sources, gutters if accessible, Any container holding water that has been standing for more than 48 hours is a potential larval production site. Note each one. Step 2. For each water source, cut 2 lengths of copper wire or rod, approximately 6 inches long. Bend a small hook at one end of each piece to allow it to hang over the edge of a container or rest stably on a pond edge without falling in completely. Step 3. Connect one copper rod to the positive terminal of your 9-volt battery using your wire and clip. Connect the second copper rod to the negative terminal. You now have a simple electrolytic cell. The rod connected to the positive terminal is your anode. This is where copper oxidation and ion release occurs. The rod connected to the negative terminal is your cathode. Step 4. Place both copper rods into the standing water, keeping them separated by at least 2 inches. Do not allow them to touch each other inside the water. If they touch you, create a short circuit and no electrolysis occurs. Rest the battery on the edge of the container or on a nearby surface, keeping the battery itself out of the water. Step 5. Leave the electrodes in place for a minimum of 4 hours. For larger water volumes, rain barrels over 50 gallons, ornamental ponds leave electrodes in place for 8 to 12 hours or until the battery depletes. The copper ion concentration builds continuously as long as current flows. Step 6. Remove the electrodes and battery after treatment. Visually inspect the water over the following 24 hours. Dead larvae will be visible as small, floating, or sinking bodies throughout the water. In clear water containers, the characteristic pale blue tint of dilute copper ion solution may be visible. This is your visual confirmation that treatment was successful. Step 7. Repeat treatment every 7 to 10 days during active mosquito season. A single 9-volt battery powers 8 to 12 hours of effective electrolysis before depletion. Budget: 1 battery per water feature per treatment cycle. At $1.50 per battery, weekly treatment of 5 water features costs $7.50 per week, still dramatically below the cost of monthly mosquito dunk replacement. For bird baths specifically, birds are attracted to the faint blue-green color that copper ion treatment produces in water and are not harmed at larvicidal concentrations. However, if you prefer to maintain clear water appearance for bird bath, aesthetics reduce treatment duration to 2 hours, which produces effective larvicidal concentration while minimizing visible color change. One important note: do not use this method in water features containing ornamental fish koi or goldfish. Fish are significantly more sensitive to copper ions than birds and mammals, but copper toxicity thresholds for fish are lower than for mosquito larvae at the concentrations this method produces. For fish containing water features, use aquatic plant coverage and biological filters as your primary mosquito control method. This electrolytic treatment is appropriate for all water features without fish. Always keep the 9-volt battery out of the water during treatment. Replace batteries that show any sign of corrosion or leakage before use. ACT 8. The close 11:00:12:15. Dr. Patricia Weston submitted her report in 1971. She was an EPA scientist who had done her job exactly as it was meant to be done. She identified a mechanism. She tested it rigorously. She documented the results. She submitted her findings through proper federal channels with a clear recommendation that copper electrolysis larval control be developed for residential application as a non-chemical, non-depleting, low-cost alternative to the biological and synthetic larvicides then entering the tenable regulatory pipeline. Her report confirmed that $3 of copper and a 9-volt battery eliminated mosquito larvae in standing water with 100% efficacy within 24 hours at concentrations safe for every non-target organism sharing that water environment. 23 years later, Summit Chemical Company launched mosquito dunks, built on the biological larvicide pathway, designed for monthly depletion, priced for repeat purchase, marketed to the same residential homeowners whose federal public health agency had documented the superior electrochemical alternative more than 2 decades earlier. For 30 years since that launch, American homeowners have been buying biological tablets that dissolve in 30 days, by design, dropping them into bird baths and rain barrels every month through every mosquito season. never knowing that the 9-volt battery in their smoke detector and the copper wire in their electrical panel contained everything they needed to eliminate mosquito larvae permanently from every water source on their property. Dr. Weston's report did not disappear because the method failed. It disappeared because a method that works permanently cannot generate the recurring revenue that a method requiring monthly replacement can sustain across 30 years of consumer purchasing. The battery costs $1.50. The copper wire costs $1.50. The mosquito larvae in your bird bath right now are 24 hours from complete elimination. And the company that spent 30 years selling you monthly replacement tablets has a problem. Subscribe to Forbidden Saving and share this with every homeowner you know who is still buying biological tablets every month when a 9-volt battery has been sitting in their kitchen drawer the entire time. Every share keeps this vault open. Every subscription preserves what the industry spent 50 years hoping you would never find. The next vault opens soon. What is inside it costs even less and eliminates even more.